Hello, good morning. Yeah, uh, this is the first talk in the morning, so no pressure. uh, Hi, I'm really happy and glad to be here because HasGeek and RootConf has been very integral part of my tech journey. I'm super excited to be here, to be honest. I'll be talking about cost optimization, not my infrastructure, but my architecture is the culprit. Uh, well, this talk actually came out after, repeatedly solving a very similar problem of cost optimization at multiple engineering orgs. And I said, hang on, I think probably this, and the patterns that I saw were very much repeated. And I thought, let me actually just jot this down and this talk, and I'll try to actually cover what are these costs that we are talking here. Who am I? I'm founder at One2N. One2N is a reliability and backend engineering consulting based out of Pune. Myself has been in 10 plus years with startups and SMEs. I started as an application engineer, then moved to data engineering, and then finally picked up the SRE jobs. Overall, I summarize myself as buzzword-driven development to impact-driven development. I love CrossFit and powerlifting and trying to go heavy as when I can. The agenda for the talk, I'll do the introduction, set some context. Post that, then we'll talk about the direct cost, which I want to cover, the indirect cost, and finally the takeaways. I see a lot of senior SRE folks here, and you must be having this economic winter comes, and your calendar is with, meeting schedule for cost optimization. And the first thing that actually comes to my mind is this tree. Now, thankfully, because of this whole of your Mid-Journey and Chat GPTs, you can actually thought your thought into images. So this is the tree that actually comes to me, is this tree with low-hanging fruits. Your low-hanging fruits are your EC2 instances, your unused volume, and your disk. Fair enough. Nice. But the tastier fruit is actually at the top, and for that, you need to climb the tree. And climb the tree means there is an engineering effort to it, right? And engineering effort, as well as the practices that needs to be followed. I have a question here. Except Sarika, in which of the engineering orgs you have the role of an architect? Please raise your hand. Okay, cool, interesting. What I read, understand, and something that really makes sense to me, that an architecture is a representation of components, systems, and the interactions between them. It's a shared collaborative understanding of engineers who actually try to make something that is on a whiteboard into reality. Now, since this is a collaborative job, it's not a single person's responsibility, and an architecture can be practiced by anyone in the team. You really don't need stars on your shoulder to qualify to do that, right? Now, the architecture that I see is like the ivory tower ones and the pragmatic ones. The ivory tower ones is, well, everything is good in the utopian world. There is an abstraction to it, and yeah, it will work. That's what we say. But when you talk about the pragmatic one, you have been in the trenches. You know that what is the ground reality. Every time you think about it, you always have, what happens if this is going to fail? Your CPU, memory, network, disk, all come into the picture that starts haunting you. And you always have the skepticism. You take it with a pinch of salt that this really may not work because of the dynamic nature and the entropy of the software system that we have learned and evolved over the period of time. And I think that's what we get paid for, right? To maintain that entropy. And finally, every infrastructure cost is justified as long as it caters to a business. And to justify, you need to have certain data points, and I'm gonna just talk about that. What is the biggest build versus buy decision that happened over a decade? That is with migration to cloud. Now, well, why it happened? Because traditional IT companies had a headache of procurement and getting your data centers, racking them up, and whatnot. Well, the cloud actually brought the elasticity of cost to you, and then you thought, this is nice. I can pay for what I use, and this is good. But hang on. Now, the predictability has gone out of the window because you can just spin up your infrastructure left, right, and center, right? And here, there are some of these direct and indirect costs that I'm going to talk about. So, enough of meta talk. Let's just talk about the direct cost. What are they? Not understanding the workload, right? So these are all the costs that I'm going to talking about, and I'll start at the not part of it, and then I'm see what are the ways and that we can progress. So cost of not understanding the workload is you have your early auto scaling, and you are running really blind about it, and you just keep on scaling things as and when it comes, right? You don't have your load testing, you do not have any capacity planning, and you say that, oh, auto-scaling gonna solve my problem. But what do you really need to do? If you have to do that, you need to, first of all, how do you avoid it? Is to, first of all, identify your workload, which is required for any kind of a capacity planning. You start by classifying your workload into transactional type or batch type. I'm sure that as SREs or infrastructure engineer, we love automation. But we don't do automation on day zero, right? We do it manually, see the repeated patterns, and then go about doing the automation. So you always start manually. You try to calibrate that, okay, what my load gonna look like. You run some load test and come to a metric which will auto scale. That, okay, based on this certain metric, I'll do that. And what are those ways? Well, you do a load test. You first of all identify the behavior of your system under load, right? You can go with your, your good old JMeters and your load runners, run these concurrent users for a certain duration of time, and identify your user journey, right? And based on that, you identify that you continuously keep on doing it till the time it actually crashes, and you observe that there is a dog pile, right? So, for example, you actually keep on bringing the servers for an auto scale, and it's talking to a single database. At certain point of time, you will hit, oh, my DB connections has been actually hit, as there are more number of applications that have auto scaled. So these are the things that you constantly are looking up for, right? So to do that, and also I think with this load test, you also try to identify if I have to evolve to a microservice kind of an architecture, is you see those repeated patterns and say that, okay, this is my particular user journey, which probably requires to scale out, so you just take this component and decouple it later on. Here, one caveat is that environment setups are costly. Use your ephemeral infrastructure because they are just used for your load test. Now, the problem with load test is that generating synthetic load can be a challenge when you are looking for a certain scale at a certain time. So what I have personally used is some forecasting model. One is this universal scalability law. Now, universal scalability law was proposed by Dr. Neil Gunther in early 90s. It's an extension of Amdahl's law. So Amdahl's law says that any task's speed up is limited by the fraction of the serialization part of it, which means that even if you throw more cores, more nodes, or actually threads, it will still be bottlenecked with the serialization part of it. For example, you can have concurrent processing for your database, but if your disks are slow, you really cannot do something about it. Universal scalability law actually is an extension to the Amdahl's law. Universal scalability law, Amdahl's law only just talks about the contention and the serialization part of the thing, which is defined by sigma. Universal scalability law, USL, talks about the coherence, which means the penalty of nodes which actually synchronize to mutate a state. To give an example, like if there are n nodes in your system and they have to have that consistency or a mutual thing, they have this charter amongst themselves, and which is actually a penalty, to be honest. So this is the only formula, by the way, which I'm talking where there is the x is the speed up, and you have like n x of 1 is like, let's say, the 50 for one node. You have the contention, which are this coefficient of this value 0.03, and you have this coherence. So when you plot this, you actually get this graph here where you say that, oh, here is my throughput, here is my nodes, and you see that the throughput actually increases till a certain point, and post that, it starts decreasing because your contention and coherence starts kicking in. Like, hang on, now why I'm talking about it, I'll actually just cover it in the next slide, why it will make sense. So you have to test the individual components, because if in your architecture you need to know the capacity of your every component and how it actually behaves, right? So you can try the load testing techniques that we discussed previously. Do it at every component. Now here is a sub-component of one of our production use case architectures. Here there is this batch request processing. Here is a dispatcher which receives a request, and it is dispatcher receives a request, just pushes it to Kafka, and orchestrator receives it. And the orchestrator actually splits this one particular job into chunks of job, and then pushes into Kafka topic partitions. And then there you have this consumer group, which actually just reads consumes from each of the topic partition, and it does some network IO bound processing, and then it gets the results, writes the raw data to an S3 bucket, and writes a trimmed down version to a database. Now, you try to get the baseline performance numbers here, right? And the baseline performance is that, okay, the time taken for processing by the workers is, let's say, 6 minutes and 14 minutes for the number of chunks that have been generated. And the time taken is for the database writes is like 3 minutes and 7 minutes. Now, what happens is, if you look at this architecture, you can actually define two things. One is that if my workload is a network IO bound, even throwing more compute would not make sense because I need a bigger network pipe, right? So similarly, for my database, if my disks are slow, even I'm writing it, my whole processing or my the job dispatching will be slow as well. Now, if the workers, they actually collect the data and are writing to that single database as well, you see that there is this whole coherence part that actually kicks in. So this database will have this own, when you are writing, internally the database will be actually contenting for the threads to have that ACID compliance. So these are all the challenges and the coefficients that you need to work upon and over a period of time tune in. And basically the idea of this forecasting is to actually just have some heuristic and give you some numbers. How do I even start autoscaling? Right? Now, you test your individual components, you identify your right hardware, you identify that is it a CPU bound, IO bound, or a memory bound. Right? And at one of the cases, I had to deal with an RDS. Here, the memory of the database was 120 gigs. The data overall was like 60 GB. They could have just overall loaded everything in the memory, and they were still facing the issues. So these are the when you don't actually understand your hardware, these are the things that comes across. The right metric for autoscaling, that's also important. So you can actually start with CPU, but I've heard many times in my interviews and discussions that I have that I'll use a CPU for autoscaling, but maybe not necessarily. What you are really looking for is a throughput or request per second, right? Now, as we talked about, that there are the systems which are the transactional ones and the batch ones. Now, the transactional ones has the response time, but it's possible that if there's a certain API which is actually writing to a network file system or a database, if that is slow, you need to probably look into there because your culprit is somewhere else, not the stateless component. The other ones are the batch ones. So the batch ones has, let's say, based on the number of background jobs. So what you can do is, if you have, how many of you used Kubernetes with HPA? Okay, pretty many of them. And how many have heard about KEDA? Okay, nice, cool. So we know. So what we were doing on one of our production use cases, that we were actually, as I talked about, that we were splitting out our chunks and sending chunks to very specific partitions. And but what happened was that we were auto-scaling based on the consumer lag, which was actually a wrong metric. What we ideally had to do, we had to just keep it on the based on number of background jobs, and then have just a 20% buffer on top of it, which will actually have a very judicious way of auto-scaling instead of just auto-scaling where all the other workers are, idle. So this was the cost of the not understanding the workload. Now I just talk about the cost of no signals but all noise. Observability, I think these days, good engineering teams have always keep this first thing in the mind, which is good. But what other problem that I have observed, that a lot of your SaaS providers and the cost actually go haywire. If you're even self-hosting it, there is of course a lot of engineering cost that needs to be invested on. Now, one thing is you can have the high cardinality for your metrics. You can keep on sending a lot of metrics at a time, and you do not have guardrails for your central logging infrastructure. So these are the costs for that. These are the friendly emails from your SaaS providers that, hey, hang on, your metrics has actually just increased. Is it really expected? So what I generally suggest, and I do with my team, is you understand your metrics. Instead of just opening the floodgate, you identify what all metrics that you would want to push to your central observability systems. Ask your team to spend some time. It's an engineering effort, but it is actually a good time to spend on it, and they realize what does it even mean. Because I always see, right, an observability dashboard that comes in is like a cockpit of a commercial airplane, where you have so many gauges, and you need to really know what each gauge means. Know about your logs. You should ignore the noise and reduce waste from anything for services which you really don't want. You should filter that out. Set your log verbosity judiciously. Set the life cycle for your log data, because how much of the time range that you would really want, and it is very contextual, business to business, that, okay, I'm fine with probably 2 weeks of log data in history, or do I need that for 3 months of the hot data? Set up alerts for your log volumes which reach beyond a certain thresholds. More ways for the cost optimization are: use compression, reduce your network bandwidth so that you actually save cost there, and keep a check on your ingress cost, because it can pinch you at times. Cost for optimization scale and used by none. Now, how about you have this big roller coaster, but nobody actually wants to use it. So we tend to prepare ourselves for internet scale before even the PMF. Using the gold standard architecture, well, okay, I have some mixed opinions on that. And identifying the unit economics of your workload as well. Like how much it's gonna cost to process one particular batch request or an API request, getting that down till there, and then you can actually extrapolate. So gold standard architecture. You can run, I've seen that, how many of you have read about the AWS well architecture framework? Okay, quite a few. Now, you have the gold standard architecture, but you should understand that do you really need it at that particular point of time? Do you need that much of availability of your systems? Maybe, maybe not, because the cost of cross AZ might again pinch you. So just be wary about it, that how much of availability you are really looking for. Again, you should be prepared, aware about it, but not necessarily implement right away. This should be in your roadmap. And as we say that you should make it functional and then actually make it fast. No unit economics. Always ask this question, that how much it, ask to yourself or to your team that how much it costs to perform a million batch requests. For example, or the example that we had previously. And you say that the expected time, maybe ask your product team that how much is the expected time do you really want for this? And they say that, okay, 4 hours, fine. And then try to get an approximate cost that it's gonna cost me $10 for a million batch request, where you consider everything, your compute, your network, your storage, and everything, and the processing, and then you can come down here. This was the direct cost. Now I'm gonna talk about the indirect cost of it. Overlooking security and compliance, the cost of ignoring the infrastructure security and good practices. I've seen it at multiple places where your components are running on public network, your RDS, your S3 buckets. You have no VPN to access your internal tools. For example, your logging or your metabase for your product team. Your secret keys are spread across all the application. How many of you have heard about the 12-factor application? Okay, cool. Now, overlooking security and compliance, say that the cloud infra is ready and are they in private network? No, not really. Every time I ask this question and I get no, my anxiety level actually reaches at a certain orbit. So this is from when you run your public services in public network, you do a public service where your database are actually compromised. This is for a friend, a first-hand experience where his DB got compromised and then he had to learn the hard way about this whole infrastructure security. By the way, you have to pay for the Bitcoin as well as to the lawyers once these scenarios happen. So these costs are like, can trickle down and shake your companies. What are the practices to follow? You can run vulnerability scan pipelines for all your assets and your cloud resources. Some of the tools that I use is Nuclei, Cloudlist, Nabu. They are open source. For policy as code, we use Chekhov. So basically, it will see that all your Terraform or your CloudFormation or your Helm files are not violating some good practices. For secret scans across, let's say, GitHub or your S3 buckets, you can use Trufflehog and Talisman. In terms of practices, do an encryption at rest always. And I'll tell you why it actually matters. By default, block everything. Be careful about this 0/0, except your public load balancers. Your components should be in private network. That should be your thought process on day 0. Use VPN. I think these days they have actually come up with much more simpler solutions what it used to be earlier to protect your internal tools as well as maintain your audit logs. Now, if you are into a fintech or where you know that the compliance is going to kick in at any point of time, be prepared and aware about it. Why? Because if you are running your production workload, those migration will be really costly. Why? Because you have to coordinate with a bunch of teams, and planning it out will be a beast in itself to actually climb that engineering effort. Shiny tool syndrome. Can anyone see the FOMO land? Yeah. Shiny tool syndrome came from a very hipster psychological concept of shiny object syndrome. where engineers are doing the resume-driven development. And I'm sure that most of us, pretty much the senior engineers, must have faced this, that we try to bend the problem around the tool because it looks cool on our resumes instead of the other way around. For example, last year, I don't want to name it, but including the new database on production based on a blog because it was just on hype on social media, and you want to include that. Stick to boring technology. Why? Because for databases, prefer your SQL DBs. The effort and the amount of engineering that has gone and the community that has been there for years and the knowledge base that you will have in your team will be there first. Cache is always not the solution. For example, every time an engineer comes, oh, I want to just put a cache and it's going to make fast. I said, hang on, what's your CPU, memory, and disk utilization? Even if it is not utilized, why don't you actually just work on optimizing that rather than just putting up one more component, because that's an overhead. So I just say this, that keep your code close and your configurations closer. Maybe you don't really need Kafka, right? You can start with an SQS, a single queue, right? And this is as an engineering practice that I have, of course, after learning the lessons the hard way, is do pair programming, have your architectural brainstorming with novice engineers that, hey, how about this database? Okay, why not A, why not B? So that you can actually explain them rather than saying that, no, just use this. So you will actually realize and they will appreciate it much better because it is just a matter of exposure for them. No collaboration. The cost of no collaborations where the architectures are kind of built in silos, right? They don't really factor the cost of ownership and the cost of maintenance of the self-hosted components. So, as I said, that architecture should be is a collaboration, is a joint effort between the product and engineering teams and your infrastructure teams. So every time you have these lities of the components has to be the cost. You should, the infrastructure team should ask how much of an uptime you want, the criticality, the quality of service that you are really looking for. Like at one time they said that, oh, we want to just run this stateful component. I'm not talking the Kubernetes stateful, it's any stateful component on Kubernetes instead of choosing an RDS. I was like, why? Why really do you want to do that? Just because it scales. No, not really. You need to understand the operation cost, the engineering effort that somebody has to keep an eye on it. And again, these migrations cost will slow you down as well because the coordination between your stakeholders and these maintenance times. The build versus buy. Every time you talk about this build versus buy thing, you end up, either you pay in cash or the engineering effort. Now, you can have your internal, and it's also a factor of your internal engineering bandwidth, the time to market, and the maintenance and support that you have to do. But I would suggest that always have, when you have to value this, see that the cost of buying is like really, really, really high, then the cost of engineering and ownership, which is very rare, but again, it comes to a use case at the scale at which you are operating. And if a component that has become very crucial and reached the limitation of an hosted solution, then you have to actually go towards the building work. Publish your cost. I think most of the good SRE teams that I know actually publish their internal newsletters. You should publish your cost to your internal stakeholders. Talk about the velocity, the deployments, the RCAs. Similarly, talk about the cost as well. And you publish the cost of your each team's infrastructure so that they are also aware that what is their budget and how much they are spending. Heterogeneity, like if you look at these buckets of ice cream, you run your ECS, EKS, and serverless. You probably don't really need it if you want to, and you just run everything at one point of time. maybe for your pre-prod you use Docker Compose, for your production you use Kubernetes. You said that I want to run a microservice, but every microservice is actually talking to the single database. So, you know, right? This is not really the heterogeneous pattern of it. Look for the homogeneity part of it. Use one way of doing things. Why? Because it just creates up the common knowledge between your team and the learning curve. Your operations become easier. If you have the bugs and issues that arise, they have the same DNA in your team. Like for example, at one of our production use cases, we started with Nomad. Why? Because the idea was to actually grow across data centers as well. But the law of the geography restricted that you need to run it across like certain cloud itself, and then it just made sense for us to use Kubernetes because of the services and the managed service solutions that are provided. So yeah, so instead of running a Nomad and Kubernetes separately would not have done any good. So hence, we had to actually change this plan. These days I play a lot with my 5-year-old. We like the spot the difference thing. And then that just makes me wonder that some of these spot the differences are like very visible to your naked eye, but some of them you need to have some effort, the engineering effort, and that is what needs to be done. Takeaways, I would say that identify the type of your workload. Do a load test forecast with USL if you are not able to do a load test. Understand the unit economics to justify your cloud cost. Have secure before audits. Security is important. Stick to boring technologies first. Product and SRE teams should collaborate more because you will have more empathy. Cost control needs cadence. It's not a one-time activity. These are some of the resources. These slides will be shared, so you can go through it. This is me, Jaideep. This is my Twitter handle. This is what I go on internet, and we have our use case and studies, which we have been writing for our production workloads. So yeah, do give it a check out. Thank you.
All right. Thank you, Jaideep, for finishing right on time.
Okay.
Cool. All right. So for everyone who has a question, we will be setting up the mic here. So this helps us in recording as well as record you and your questions basically. So anyone with a question, please come over.
The spot with you as well here. Hey Jaideep, this was wonderful, thank you. Quick question, I go back to one of the points which you said it is about having a commonality within your organization in a way of structuring your code base of the technology is similar so that the knowledge sharing and the executions can be related. Yeah. I mean, is that applicable more towards the startup type of culture, or do you think it can go on to the bigger, because in the world of talent challenges and whatnot, you can't really be searching for the similar type of talent for your whole fleet of applications. So I'm just curious on that particular one. That's very interesting, as is what you said.
Interesting question. Actually, more than the startups part of it, it is just the cultural practice, and that requires a continuously repeating yourself. If it has to be like an education and awareness to your teams. You need to have more collaboration, talk about it. Usually it is like engineering leaders and organization. If you are an engineering lead at one vertical and at the other vertical B, for example, let's say an SRE engineering lead and the product engineering lead, you need to talk about it, collaborate. I have seen a lot of friction points, But the way is to actually just talk about it and onboard like small teams, show them the benefits of it, that, let's just stick to this, so that the ownership and everything, your SRE team can actually help as well. If we opt collaboratively, rather than you going your own way, because my engineering team, if I'm the SRE lead and you are the product engineering lead, my engineering team won't be able to support it. Probably they don't have the knowledge base, because the tools that have been homebrewed or used off the shelf over the years, and the knowledge that has been created will be hard. Hence, so again, there's no silver bullet to it, but it's a cry continuously repeating itself.
Any other questions? Go ahead.
All right.
But of course, you will have some question comes to your mind later. You will always have the opportunity to ask it, ask it for wherever you want to, and you will have to answer that. And of course, we will cast them outside the house. So, let's go ahead. That's it.